Hello everyone! Have you already noticed the box Same Individuals Among Groups in Simulx? This week I will show you when it becomes useful and how it will impact your simulation. Right now you see that the option is grayed out, meaning that in my project the option is not relevant. To learn about this option, I can load the demo project involving it by clicking on Project, Load Demo. For almost every feature in Simulx, we have an example project showing a case where the feature is relevant. I will probably find the demo project for this option in the folder Simulation because it is an option from the Simulation tab. And here it is. I load the project Simulation Group Same IDs in Groups. In the Simulation tab, the option Same Individuals Among Groups is now available because several simulation groups are defined. To understand the context of this example project, let's have a look at the model. We have a standard PK model. The output is the concentration in the central compartment, and we have a covariate effect of race on the bioavailability. Now let's have a look at the simulation setup. We simulate 3 groups of 42 individuals each. The 3 simulation groups differ by the treatment administered to the individuals: a low dose, a medium dose, and a high dose. But all other elements are the same. Among the shared elements, we have a distribution of covariates with an equal probability of the 3 categories, and we have the population parameters. Let's see what Simulx will do when I click on Simulate. To generate the 42 individuals, we sample covariate values based on equal probabilities for the 3 race categories. We then sample parameters for each individual. For this, we pick random effects, eta, from a normal distribution, and we compute the individual parameters using the distribution defined in the model, the covariate values, and the random effects. See here, for example, how we compute the bioavailability parameter. We sample random effects from a normal distribution with deviation omega f given in the table of population parameters. F follows a log normal distribution, so we compute f with the following formula. Fpop is given by the table of population parameters, and depending on the race of the individual, we add beta Caucasian, beta Asian, and 0 for a Hispanic, which is the reference category. Finally, we add the random effect that we just picked. Doing this for all individuals and all parameters, we obtain a full table of individual parameters that we can use to simulate a whole population. Now let's see how the 3 different treatments are applied to simulate groups. If Same Individuals Among Groups is enabled, the sampling will be performed only once to obtain a single table, and the 3 treatments will be applied to each individual of this table. In my example, Same Individuals Among Groups is enabled. I simulate the project. I obtain, indeed, 3 times the same table of 42 individuals, 1 for each group, and you can check that all covariate values and parameters are the same in these 3 tables. In the plots, I see how the PK concentration evolves for the 3 different treatments. Here the difference in the group predictions is only due to the treatment. This simulation setup is useful to understand the impact of the treatment on a population, making sure that the difference you observe is not due to the randomness of the sampling steps. Now, if Same Individual Among Groups is disabled, the sampling will be performed 3 times to generate 3 different populations. And a single treatment will be administered to each population. The first dose amount to the first population, the second dose amount to the second population, and the third dose amount to the third one. If I untick Same Individuals Among Groups and simulate again, I can check that I obtain 3 different tables of individuals with different covariate values and different parameter values. The difference in the plots here is due to the difference in the treatment, but also to the difference in the individual parameters sampled in each group. The simulation setup is closer to the real case of a clinical trial with parallel design, when one can only compare different treatments by defining different arms. It can help you decide whether you will be able to notice the difference in treatments, despite the variability between the participants in the three arms. In brief, the decision to enable or to disable same individuals among groups depends on the goal of your simulation. To focus only on the impact of the elements differing between groups, for instance, to investigate candidate dosing regimen to reach a specific target, enable same individuals among groups. To predict if elements will lead to a significant difference in parallel arms of a clinical trial, make sure the option is disabled to include the variability coming from the shared element as well. Have a nice week!